A drug fails in trials after 10 years of development and 2 billion spent. And it's not because the science was wrong. The problem was that nobody could predict how the molecule would behave inside the human body. Graph neural networks, or GNN, is changing that. Now, the problem with traditional neural networks is that they were built for structured data. I'm talking rows and columns, grids of an image, sequences of a word. A molecule is none of those things. A molecule is a network of atoms connected by a chemical bond. So the relationships between atoms, like which ones are bound, how many bonds, the angles between the bonds, those are the entire signal of a molecule. If you strip away those relationships and flatten the molecule into a table, then you have lost the real information that actually matters. Now, graph neural networks are deep learning models built specifically for graph structured data. Basically, nodes represent entities and edges represent the relationships between those entities. If you apply that to a molecule, every atom becomes a node, and every chemical bond between those atoms becomes an edge. The mechanism that makes graph neural networks work is called message passing. Basically, each atom node sends an information about itself, like its element type, the charge, and the bounding state. It sends it to every atom that it is bounded to. Now, those neighboring atoms receive that information, they combine it with their own, and they pass an updated message further along the graph. After enough rounds of message passing, the graph neural network has built enough numerical representation of the entire molecule. So now it has captured the individual atoms and the structural relationships between them. So in drug discovery, predicting how the candidate molecule will bind to a target protein determines whether it moves forward or gets scrapped. So graph neural networks are actively used in drug discovery. They are also used in molecular research because they capture the relationship that traditional neural network needs. So instead of synthesizing thousands of compounds in a lab and testing them one by one, a process that can actually take many years, a graph neural network can screen millions of molecular candidates computationally. It can predict their binding behavior, their toxicity, and stability before a single compound touches a test tube. That's how graph neural network saves time and money. If you want to see how graph neural network do all this message passing mathematically, I'm going to drop a link to the research paper in the comments. If you enjoyed watching this video, make sure you hit that subscribe button because this is Tech with James, where AI makes sense. Bye.